Hello. So this video is going to be about simplifying square root expressions, and eventually we're going to talk about how to simplify square root expressions with negatives on the inside, okay? So just kind of quick review. If I take the square root of a product of two of the exact same thing, so in this case I just use b times b. If you take the square root of that product, you're just going to get the value that you're multiplying. So b times b would just give me b. All right, so let's break this down. I want to show you how we did this in class last time. So again, this is just a little bit of review. I'm going to break 45 down into a product of two values. So I know 45 is 9 times 5. I can break 9 down even further to give me 3 times 3 times 5. And I can now break this down into the square root of 3 times 3 and the square root of 5. Now that property that I just referred to says, okay, well, if I have the square root of 3 times 3, that's just 3. All right, and I still have the square root of 5 at the end of my answer. Okay, so if you reduce the radical of square root of 45, if you extract out all the perfect squares, you get 3 square root of 5. Okay, so let's do it again. We have a few examples here. We're just going to break them down slowly but surely. So I'm going to break down 140. Now there's a lot of ways we can break this apart. I'm going to use 14 and 10. There we go. And I'm going to break down 14 even further. So again, this process is called prime factorization. So 14 would be 2 times 7, 2 times 5 for the 10. And I like to write them in order. Okay, now that's completely up to you, but when I write them in order, you can see exactly what you have here. I'm now going to break this apart. I'm going to say I have the square root of 2 times 2, the square root of 5, and the square root of 7. The square root of 2 times 2 is just 2. And then I have the square root of 5, and I have the square root of 7. Now, if you ever have two radicals that you can't reduce, that you can't simplify, we can just put those back together, and that gives me 2 square root of 35. Again, when we put them back together, we're multiplying them, right? It's the square root of 5 times the square root of 7, so that's how I get 35. All right, I have more. We're going to keep doing this. My numbers get a little bigger here, but that's okay. So when I get a big number like the square root of 396, right, I have my calculator here. I need to find two numbers that divide into that. So 396, I'm going to kind of divide this by 3. So I have 3 times, now according to my calculator, I have a 132. So I really can't break down 3 any further, but let's see if I can break down 132. So 132, I'm going to divide that by, 3 again, which is 3 and 44. Again, we don't want any decimals. Okay, so we want to figure out what numbers divide into it evenly with no remainders. Okay, so I have a 3, I have a 3, and then I can break down 44 into 4 and 11. Now I'm working with numbers I'm a little bit more familiar with. So I have a 3. I can break 4 down into 2 and 2. 11 is prime. That doesn't break down. So now I have the square root of 3 times 3, the square root of 2 times 2, and the square root of 11. So if I do this, I know I'm going to have a 3, I'm going to have a 2, and we can't really reduce the square root of 11. So I would write my answer as 6 square roots of 11. And that would be my answer. Okay, so let's keep going. Now I have a number out front, I have a 5 out front, but that really doesn't change how I do this problem. If you remember from last week, I just leave that 5 out front, and I'm going to break down the square root of 147, okay? So this radical is really what I'm worried about. I'm not really worried about that 5 in front. So what can divide 147? So I'm thinking 147 divided by 7. I have a 7 and a 21, okay? So I can break that down further. 7 is prime, so that stays. 21 can be broken down to 3 times 7. And I still, don't forget, I still have that 5 in front. Okay, so now if I reorder this, if I rewrite this, so all my numbers are in order, I have a 3 times 7 times 7. I can break it apart. So the 5 just stays out front. I have the square root of 3 I can't really do anything with, but I do have a square root of 7 times 7. So that gives me 5 square root of 3, and then the square root of 7 times 7 is just 7. Again, you need a pair. You need 2 of those numbers. So I'm going to multiply the 5 and the 7 together. That gives me a 35. And then inside my radical, all by itself, I have this 3. So this would be my answer. Okay, so if you have a coefficient out front, we don't really do anything with it to the end. We're just going to multiply it into our answer at the end. Okay. All right, so here's the new part for today. This is the new piece. So I have 2 problems side by side here. We're going to do them 99% the same way. Okay, so the one on the right, the negative square root 75, has a little extra piece to it. But I want to show you kind of how this works. So what I'm going to do is I'm going to break this apart into 25 times 3, the same way we've always done, right? And I can break apart the square root of 25 to be 5 times 5 times 3. And that gives me a square root of 5 times 5 times the square root of 3, which is just 5 square root 3. Now, for the second one, because it's negative, we have this extra little piece. And I'm going to try and color code this the best I can. So what we're going to have is, if I have the square root of a negative 75, I'm going to first break this apart into negative 1 times 75. Now, one thing I want you to know, okay, is the square root of negative 1. Let me write this out. So if I broke that apart, the square root of negative 1, we have a special symbol for this, and it is a I. Okay, so I have an I square root 75. Now we're going to do everything that we just did on the previous problem, right? So when you take that I off, now I have a 25 times 3, again, with that I in front. Then I have an I times 5 times 5 times 3. I have an I times the square root of 5 times 5 times square root of 3. And the square root of 5 times 5 is just 5. So we have a 5 and an I out front and a 3 left inside. So compare those 2 answers. The 2 answers are exactly the same, except for the one on the right has this special symbol in it, I. And I stands for it's a silly term, but it's called an imaginary number. Okay? You have to include that symbol in order to have full credit. So anytime we have a negative inside the radical, we will always have an I in my answer. So I have a few of these just to show you. So when you have this negative value on the inside, I'm going to write an I and then just square root of 112. Okay, so anytime you have this negative, we're just going to pull that I right out in the very beginning. And now we can reduce the square root of 112. So if I keep my I out front, I can now break up this 112. Now I got to think here for a second. 112 divided by I'm going to say 2 is going to be 2 and 56. And then I still have this I out front. 2, I can break down 56 into 7 and 8. I have a 2 times 7. I can break the 8 down into 4 times 2. Notice I'm just breaking everything down here. So 2 times 7. The 4 can be broken down a little further. So I am going to write this. I have 4 2s. So I want to make sure I write all 4 and a 7. So if I start to break this apart, I have an I, 2 times 2, 2 times 2, and a 7. So I still have my 4 2s and a 7. So I'm going to have I times 2 times 2 times square root of 7, which gives me I times 4 times the square root of 7. And you can actually multiply those. I would write this as 4I square root of 7. Okay? And that would be my answer. All right, let's do it again. Again, feel free to pause, rewind, fast forward if you need to, okay? So again, I have this negative, so I'm going to have an I out front, square root of 49. I'm going to break down 49 into 7 and 7. Do not forget about that little I. And if you notice, well, 7 times 7, right? I can't break those down any further. So this just gives me I times 7, or we would write that as 7I. Okay. I have a ton of examples. So again, practice makes perfect. So here's a number that's a little bigger. I have a negative out front. So I'm going to have an I square root of 117. I'm going to break down that 117. Now I have my calculator here. 117, I'm going to try to divide it by 3. Yep. So I get 3 and 39. So again, you have to find two numbers that multiply to 117. And we do this just like we've done for all the other problems. 39, I can do 3 and 13. Now I can't break down 13 anymore. So I'm going to start to write this as 3 times 3 and square root of 13, which gives me an I times 3 times square root of 13. And I would write my final answer here, as a 3I square root 13. Okay, and that's my answer. Let's keep going. Now I have a 7 out front. So when I take this negative out, it's now going to become a 7I. Square root 28, not 27, 28. So if I break that down, again, keep the 7I out front. This is going to be, I'm going to say 4 times 7 is 28. I can break down the 4 into 2 times 2. And I can break this down even a little further. 2 times 2, and then I'm going to separate the radicals. So I have a 7I times 2, and I square root of 7 on the inside. So I can multiply those values out front, and that gives me a 14I square root 7. That would be my answer. It's like the examples never stop here, okay? So again, fast forward, rewind, look at what you need to. I just have some interesting problems. The problems will get more complicated as we go, so make sure you take a look at all of them. I'm going to take this negative out front, and when you take that negative out, don't forget your I. So I had a negative 9 to start. Now I have a negative 9I. And then inside, I have a 63. So now I have a negative 9i. I'm going to break apart the 63 into 9 and 7. I can break the 9 down further into 3 and 3. And I can now separate my radical, which gives me, I ran out of room, but negative 9i times 3 times the square root of 7, right? Because we can reduce that first radical. And I get a negative 27i square root 7 is my answer. Okay. All right, so this one looks a little different. All right, I just want to show you a few things here. So this negative 4i, we're not doing anything with right now. It's a separate term. What I want to do is I want to simplify this radical the same way. So I'm going to have 6i square root 9. This negative 4i stays there. And then I'm going to say plus 6i, and I can break apart the 9 into 3 and 3. And I have a negative 4i plus, let me get my pen working here, 6i, and now square root of 3 times 3 is just 3. So that gives me a negative 4i plus 3 times 6i is 18i. And we can actually add those together. Negative 4i plus 18i is a 14i. Okay. So all I did is, as I used our idea, we reduced the radical first, right? And then after I reduced the radical, then I just combined like terms. That's it. Okay. So I just reduced the radical and then I had two terms. I just combined them together. So I want to do the same thing again. Okay. Right. So if we do this, I'm going to start. I have an 8i plus, now I have a negative on the inside, so that's a 2i square root 36. Now I can break this down into 3 times 12. Right, so I want to make sure I write everything out. So I have a negative 8i, right? So I bring it down. If I keep reducing this, this is now the square root of 3 times 12 is 2 times 6. And I can break that down even further. Three times 2, 3 times 2, right? I like to write that in order. I'm going to do that up here to give myself some more room. So I have an 8i plus a 2i square root. I have 2 2's and 2 3's. So I'm going to have 8i plus a 2i square root 2 times 2 square root 3 times 3. So I have an 8i plus a 2i times 2 times 3. And I can actually multiply that together. So everything in blue can combine. So 2i times 2 times 3 would give me a 12i. And if you add those together, because they are like terms, I get 20i. That's my answer. Okay? So you can kind of see it in practice. So here's the big idea. When we have this, when we have that negative inside the radical, Okay, we can take that negative out. That's where I get my I from. And then break down your radical, right? And we get our answer. Now there is one other property that we're going to touch on eventually, and it deals with this I squared is a -1. Okay, but that's going to be for our next lesson. That will be on Thursday of this week. We're going to really get into those I squareds. We're going to do some operations with these imaginary numbers. Okay, so you can see they'll look something like this. All right. Hopefully that helped you reduce radicals. Hopefully now we've also expanded it so we can reduce radicals with negatives on the inside. If you need anything, feel free to email me and ask.